Hey Ethan, can you help me with my Spanish homework?
We start off with the expression x cubed minus 6x squared plus kx plus 42. We know that its zeros form an arithmetic progression, so the expression can be written as the quantity of x minus r times the quantity of x minus r plus d times the quantity of x minus r plus 2d, where r is the first zero in the arithmetic progression and d is the common difference between the zeros. When we expand this expression, we get negative r cubed plus 3 times r squared times x minus 3 times d times r squared minus 3 times r times x squared plus 6 times d times r times x minus 2 times d squared times r plus x cubed minus 3 times d times x squared plus 2 times d squared times x. This expression is equal to x cubed minus 6x squared plus kx plus 42. So the sum of the terms that are being multiplied by x cubed should equal 1, which they already do. The sum of the terms that are being multiplied by x squared should equal negative 6. The sum of the terms that are being multiplied by x should equal k, and the sum of the terms that do not include x should equal 42. With that, we get negative 3r minus 3d equals negative 6, 3r squared plus 6 times d times r plus 2d squared equals k. And negative r cubed minus 3 times d times r squared minus 2 times d squared times r should equal 42. Using the first and third equations, we can solve a system of equations involving r and d. We get that r equals negative 3 and d equals 5, or r equals 7 and d equals negative 5. Regardless of which pair of r and d we use, plugging in the values into the second equation will result in k equals negative 13.
Hey Ethan, can you help me out with astronomy?
Plugging in z for x in the first equation should give us c to the fourth plus c to the third plus 5z squared minus z to the 10z plus 6 equals 0, since z is the zero of the expression. Plugging in 2z for x in the second expression should give us 16z to the fourth plus 8bz cubed plus 4cz squared plus 2zd plus e equals 0, since 2z is the zero of the expression. Taking 16z to the fourth plus 8bz cubed plus 4cz squared plus 2zd plus e equals 0, and dividing both sides by 16 gives us c to the fourth plus b over 2 z cubed plus c over 4 z squared plus d over 8z plus e over 16 equals 0. Since both equations equal 0, we can set them equal to each other. We notice that these two expressions can be set equal to each other if we set coefficients equal to each other. The leading coefficients are already 1, so that doesn't need to be changed. The coefficient of the z cubed terms of both sides are b over 2 and 1, so b halves equals 1, which results in b equals 2. The coefficients of the z squared term are c over 4 and 5, so c over 4 equals 5, which results in c equals 20. The coefficients of the z terms for both sides are d over 8 and negative 10, so d over 8 equals negative 10, which results in d equaling negative 80. And last but not least, the constants for both sides are e over 16 and 6, so e over 16 equals 6, which results in e equals 96. We're looking for b plus c plus d plus e, so we add all of these together, which gives us 38.
Hey Ethan, I need help on the history of ships.
First, we have to find the values of x where x to the 6 equals 1.
The values of x where x to the nth power equals 1 can be written as the cosine of 2 pi k over n plus I times the sine of 2 pi k over n.
The values of x can be written as the cosine of 2 pi k over 6 plus I times the sine of 2 pi k over 6. We can plug in the values for k from 0 to 5 to get all the values for x. We do not try 6 since it would give us the same result as k equals 0. If k equals 0, then x equals 1. If k equals 1, then x equals 1/2 plus the square root of 3 over 2 times I. If k equals 2, then x equals negative 1/2 plus the square root of 3 over 2 times I. If k equals 3, then x equals negative 1. If k equals 4, then x equals negative 1/2 minus the square root of 3 over 2 times I. If k equals 5, then x equals 1/2 minus the square root of 3 over 2 times I. Now we're looking for values of x where x cubed does not equal 1. Testing out 1, we get 1, which does not work. 1/2 plus the square root of 3 over 2 times I gives us negative 1, so that works. Negative 1/2 plus the square root of 3 over 2 times I does not work since it gives us 1. Negative 1 cubed gives us negative 1, so negative 1 works. Negative 1/2 minus the square root of 3 over 2 times I does not work since it gives us 1. And 1/2 minus the square root of 3 over 2 times I works since it gives us negative 1. So the values of x where x to the 6 equals 1 and x cubed does not equal 1 are 1/2 plus the square root of 3 over 2 times I, negative 1, and 1/2 minus the square root of 3 over 2 times I.
Ethan, you are a mathematician.